The chord, what is chord? This chord is a line segment drawn between 2 points along the circumference of a circle. Okay, secant could be, it could go outward of the circle. It's not drawn exactly on circumference, but chord is drawn on the line segment drawn on the 2 points, between 2 points. Here A, B, you can see A and B are 2 points. That 2 points should be exactly on circumference. Okay, and the line segment should uh, limit or end between the circumference of the circle. So it's the distance or line segment drawn between the points on the circumference of the circle. So when two chords intersect inside a circle, you can see in the circle we have AB and CD are two chord and is set exactly at E. Then AE into EB will be same as CE into ED. This is only when two chords intersect inside a circle. When two chords intersected, they would obviously intersect at some common point. So then I can write AE product of the two chords between one chord is equal to same as the product of equal parts of the other chord. AE into EB equals C into ED. If two secant, okay, you can see this is not a chord, this is a secant, this extend outwards. If two secants are drawn to a circle from one exterior point, uh, then it will be AB into AD. The product of AB into AD will be same as AC into AE. Okay, the total distance. Two secant. This is the case of secant. This is for chord. Okay, this is secant. Two secants are drawn to a from the some same exterior point. Then this is identity. Then one secant and one tangent are drawn here. AB is the tangent and AD is the secant from a common exterior point. Here is the exterior point. Then AB square. That means square of the length of the tangent will be the same as the product of the two parts of the secant AC into CD. AC into AD, the total distance AC into AD. C is the point that the secant intersect on the midway of the circle. AC into AD. Okay, one secant and one tangent are drawn from same point. Sorry, from one exterior point A. Here common point A. Then AB square is equal to AC into AD. So today I will be discussing the topic circles on mensuration. So circle is a set of all points in a plane which are at a fixed distance from a fixed point. Right. As you can see, all the points, if I just join all the point which is at a fixed distance from its center, I will get a circle. The set of all points in a plane which are at a fixed distance from a fixed point, that is called circle. So you can see it is having a radius d, sorry, radius r and diameter d, which is simply circle. Tangent to circle is a line which touches the circle at exactly one point. Okay, it could be like this, it could be like this, it could be any way a tangent can occur at a circle, and the that the main point is it touches exactly at one point is called tangent of a circle. As you can see in the above circle, PQ is the tangent for the circle, and at the point T. Okay, only one single point tangent is touching. For every point on the circle, there is unique tangent passing through it. Okay, there is an infinite number of points in this circle, and for each point would have its own unique tangent passing through it. Tangent is always perpendicular to the radius of the circle at the point of tangency. Here AB is the tangent to the circle, so it touches exactly at one point. Here AB is the tangent touching exactly at T. So tangent will be perpendicular to a circle. So okay, exactly 90 degrees. So tangent is always perpendicular to the radius of the circle at the point of tangency. Okay. The two tangents drawn from external point to a circle are equal in length. Suppose we have a circle down here. That is a point P. So two tangents are drawn from this point B to this circle. Uh, Obviously should be equal in length. Okay. That's only possible because we are drawing it from the same point to the circle. So it will exactly touch at the parallel or coincident points of the length will be equal. AP is equal to PB. So that's a law. Two tangents drawn from an external point. The same point, if two tangents are drawn to a circle, that two length will be same. And a quadrilateral, so you can see here is a quadrilateral OA PP. Okay, so in this case, there will be a quadrilateral is formed. So I can say that angle AOB plus angle BPA is 180 degree. There is an angle formed, the interior angle inside the circle, and the angle subtended by the two tangents to the circle together form 180 degree. Angle AOB plus angle BPA equal to 180 degree. The two direct common tangent drawn to two circles are equal in length. Okay, two direct common tangent. As you can see, we have one larger circle and smaller circle. So WX and YZ are the common tangent to both the circle. So two direct common tangent which is drawn to these two circle, it should be equal in length. That means WX and YZ are equal in length. Next one is the cycle quadrilateral. Cycle quadrilateral. Okay, what is it? Quadrilateral. Okay, quadrilateral circumscribed in a circle. Circumscribed in a circle means the quadrilateral is inside the circle. Then it would be called cycle quadrilateral. So for a cycle quadrilateral, you can see ABCD is a cycle quadrilateral because it is circumscribed inside a circle. So angle A plus angle C 180 degree, angle B plus angle D. That means sum of opposite angle diagonally opposite sum of the diagonally opposite angle in a cycle quadrilateral is 180 degree. So I can write also one identity is angle A plus. I mean all the angle, sum of the angle, all the angle inside a cycle quadrilateral is 360 degree. Okay. So radius of a cycle quadrilateral. How do you find the radius R of a radius of cycle quadrilateral? If I know A, B, and C, A, B, C, and D with a successive side. Okay, adjacent one after other A, B, C, D are successive side. If I know the value of A, B, C, D, and S is a semi-perimeter of the cycle quadrilateral, then I can use this formula. Find the radius of the cycle quadrilateral 1 by 4 into square root of AB plus CD into AC plus BD into AD plus B all divided by S minus A into S minus B into S minus D, where A, B, C, D are successive side and S is semi-perimeter of the cycle quadrilateral. So this is to find the radius of the cycle quadrilateral. To find the area of the cycle quadrilateral, simply apply square root of S minus A into S minus B into S minus C into S minus D. If there's a quadrilateral which is inscribed in a circle, then product of the diagonal is equal to the sum of the product of its two pairs of opposite side. Okay, P and Q. Suppose P and Q are the two opposite diagonals of the cycle quadrilateral, and if taken A, B, C, D in the same order, of course A and C will be the opposite side, and B and D will be the opposite side. So as it says, product of the sum of the product of the opposite pairs will be equal to the product of the diagonals. PQ is equal to IC plus BD. This is for cyclic quadrilateral. Okay, we have the equation for area. To find cyclic quadrilateral, we have the equation for finding the radius of the cyclic quadrilateral, and we have this point P equal to AC plus BD. If E is the point of intersection of the two diagonals, suppose A, B, AC and BD intersect. If E is the point of intersection of two diagonals, then AE into EZ is equal to BE into ED. Okay, where they have mentioned O, suppose we have here E, then AE into EZ is equal to BE into ED. Okay, the exterior angle formed if any one side of the cycle quadrilateral produced is equal to the interior angle opposite it. Okay, if an exterior angle is formed, if any one of the side, suppose it could be any of the side AB to AB could be BC, CD or AD. If the exterior angle formed, if any one side of the this cycle coordinate produced is equal to the interior angle opposite it. Okay, the interior angle that will be made opposite to that will be that will both will be same. If any one of the cycle coordinate is produced, any one of the side of the cycle coordinate produced, and that must be equal to the angle. The exterior angle formed by that would be equal to the interior angle opposite to it. So next one is the angle in a circle. Inscribed angles subtended by the same arc are equal. Okay, as you can see, these are all inscribed angles, and that is subtended by the same arc. Okay, as you can see, AB is the arc here. So all the angles subtended inside. If I draw from this AAB, if I make any arc or any angle, the angle subtended I can draw like this. I can look this with these 2 point A and B. The inscribed angle between that arc AB, I mean same arc. If any way to draw by using this A and B, all that angle would be same. Inscribed angle subtended by the same arc. Where the AB is the arc here are equal. Then angle subtended by the diameter is 90 degree. Okay, if this AB is the endpoints of the diameter, I would say that that angle subtended would be exactly 90 degree. Okay, the angle subtended by the diameter is 90 degree. So this point is a continuation from the previous figure. The length of the direct common tangent. Okay, we have mentioned the common tangent Wx and Yz. So the length of the direct common tangent to the two circle. Not to find the value of the common tangent is square root of d square minus r1 minus r2 the whole square. R1 and R2 are the radius of the first and second circle. For d is the distance between the centers of the circle. I mean, the center to center distance. Okay, distance between center of the circle and R1 and R2, the radius of the given circle. So it doesn't matter if you take R1 and R2, if you don't interchange, it would be negative. It doesn't matter because we have a square, so it will be basically positive. Simple formula is square root of d square minus difference in radii of the square of the difference in radii of the two circles. That's how we find the common tangent, length of the common tangent. Next, what is a secant? Secant is a line that intersects a circle in exactly 2 points. So secant can be in any form. It could be drawn like this. It could be drawn like this. It should exactly intersect at any 2 points. So tangent has to be intersect at exactly 1 point. Similarly, secant is a line that intersects a circle in exactly 2 points. That's what called as secant. So when two secant intersect outside a circle, you can see this PD and CR2 secant in a circle. So by extent, they would meet at point A. So if two secant intersect outside a circle, then the measure of angle formed is one half of the positive difference of the measure of the intercept R. That means angle A. Okay, that's the measure of the angle formed due to the extension of secant. That will be one half of the positive difference of the measure of the interceptor angle. Here the interceptor angle you can see BOE and BOC. Okay, that will be the two interceptor angle formed by the secant. So if I take the positive difference, these two angle could be of any angle. So whatever it is, you have to take the positive difference. Half of the positive difference of the measures of the intercepted arc. Okay. If I can draw BOC and BOE, so the difference between the angle of these two, half of that positive difference between the first half of the positive difference of the angle between BOC and DOE will be the angle formed by the extension of secant. Okay, this is a point to be remember. And this is the final point regarding circle in mensuration. The angle subtended by an arc at the circumference of a circle. Okay, is half the angle subtended by the same arc at the center of the circle. Here you can see the angle subtended by an arc at the circumference of a circle. Okay, we know this is the circumference. So the angle, this is an arc. Suppose we have an arc here. You can see, right? So it's an arc down here. So this arc is angle is subtended by an arc, right? At the circumference of circle, and there will be an angle. You can see there that angle X, and that will be half of the angle subtended by the same arc at the center of the circle. This is AB. Yes, we don't name it, right? So suppose we have this is the arc we are talking about. So this angle is subtended angle at the center, right? This is the arc, and that arc is subtended angle at the center, that angle will be double the other angle, or you can say the angle is subtended by an arc at the circumference of a circle is half the angle subtended by the same arc at the center of the circle. Okay, so it will be x because it's half the angle of this angle subtended at the center. Okay,